Welcome back to the shop. More power drawbar troubles. Don't do what I've done. First up, I've got my Arduino installed and a relay shield, a separate relay and a power relay that drives the linear actuator. You probably see the linear actuator is missing. I'll explain that in a moment. 24 volt, 200 watt power supply, I think 250 watts. To detect the ends of movement, this is the cylinder that goes up and down, and I've got a magnet bolted to it and two magnetic sensors, and so on the bottom of stroke this sensor gets triggered and it turns the power off, and then at the other end this one when it's triggered turns the power off. So so the linear actuator will only move between these 2 points, which means that you can speed up how fast you can change the tool. Good idea in theory. In practice, is it worth it for people like us? Well, I mean, we're hobbyists. If it takes 30 seconds to change the tool as opposed to 12, are we really that bothered? Probably not. Okay, so after this has fought me, this whole project has fought me from the very start. This, I finally, after 3 weeks of fiddling, which is why you haven't seen me for 3 weeks, after 3 weeks of fiddling, I've got the software to work reliably. If you put your foot on the pedal, then the drawbar opens, and on the control panel, I've had to move the control panel out of the way, but on the control panel the light reacts as you'd expect it to. Whilst this is active, you're locked out from here, so you can't change state within while it's actually moving. So you either have the button to open the collet or you have the foot switch. The foot switch is temporary, so it only opens while you've got your foot on it. It opens. When you take your foot off it, it closes. The switch on here is latching, so you push the switch, opens the collet and stays there, waits for you to push the this then flashes, and then when you push it again it closes and the light goes out. Perfect. It's also interlocked, so if the spindle is spinning, my thinking, then neither of those buttons will work, the foot switch or the control panel. And finally, it also takes a control signal from the collet being open through here. So if the collet is, the tool is open and effectively the spindle is jammed, because that's how these things work, it sends the signal via here through to the control panel, and eventually when it's fully wired in, will go through to the computer that drives it, that will say that will hit the not an e-stop, but it will hold it in stasis. And I'm going to use the control cable or the control pin that tells the machine the door is open. So again, eventually I'll put another proper cabinet on this thing. Now I just realised you can't quite see. There you go. Eventually I'll put a proper control panel. That's another word I'm looking for. Eventually I'll put this in a proper box. It chucks stuff out the top at the moment, so it needs to go in a proper steel cabinet. Anyway, that's by the by. So when I do that, I will probably have a sliding door, and the sliding door being opened will halt the program, or the collet being open will do the same thing. It will halt the program, so you won't be able to move forward. That's all good. Let me show you what I've done wrong. I shortened the length of the stroke of this by moving the end stop micro switches. Now, at the time, if you read on the side of these micro switches, they're rated at 125 volts at 10 amps. That, in theory, is enough to make this drawbar work correctly. In practice, they're not 10 amp micro switches. They one of the extended one, which is when the thing's under load, has burnt out. So that caused a few problems. I thought, can I put a bigger switch in, and I came to the conclusion that no, I couldn't. That is why I went for these micro switches and a little magnet. So I've replaced the switches that are in the actual linear actuator with these, which in theory is a good idea. There are problems with micro switches, not micro switches, with reed relays, which are what these things are. They have a tendency to stick, so you can get them trigger, and then when the magnet moves away they stay triggered, which is a bit of a pain. So today, ahead of doing final testing before I made this video, I thought I'll just do a little piece to show you the electronics in the drawbar, tell you a little bit about how the code works, and then we'll button it all up and then we'll show you it working. However, this is what happened. Right, here's the actuator. So I took it apart because what I thought had happened is I thought one of the switches, which I think they're still wired in circuit, I hadn't taken them out completely. I thought one of them has gone intermittent, and I'm getting some variable results when the motor tries to draw a bit more current because it's hitting the load, pushing the tool out. I thought, okay, one of these micro switches is not allowing enough current to pass through. So I thought, oh, I'll just take it to pieces and have a look. And in doing so, let me see if I can focus this up. There you go. In doing so, on the worm gear, I thought, that doesn't look good. Nylon. So if you look in there, I'm really not sure this is going to work. Yeah, if you look in there, you can see the corresponding gear, the nylon gear, is thoroughly stripped. So I have a choice. Do I strip out the gear out of that linear actuator and try and make another one out of brass? Probably a good idea. Difficult to do. I'm not entirely sure I can cut helical gear, but be an interesting thing to try. Or I can put another actuator in, and that might be a reasonable thing to do as well. But my feeling is that another actuator would have a limited life, exactly as this one has, and also I'm not really that keen on spending another £65–75 to buy one and then wait 3 weeks for it to turn up from China. So yeah, I have a source of another, or there is a source for more linear actuators which might pay dividends, but we'll see. My late father had a mobility scooter, and he had mother actually had one, and he had a lift because he couldn't lift it in the boot of the car, so it had a little hoist, if you like, and that was the one that's in the car at the moment is the second one. The first one, I actually took it out because they wanted a better one, so I took it out and I kept it here in the workshop, because ultimately I've found that putting the big lathe chuck, the 4-jaw chuck, on my lathe can be a bit tricky. So I thought, I wonder if I could turn that into a hoist at some point, just to hold the chuck stationary while you slide it on. That's how they used to be when I was at college. So I thought, yeah, might be a good idea. However, here's the arm that I was going to use, and that has a large linear actuator on it. It says it's only rated for 3,000 newtons maximum push, and this motor is readily available should this thing go belly up. This is a windscreen wiper motor, so I thought, yeah, maybe that's the way to go. But I've used windscreen wiper motors before for various machines, and they're the same. The main gear in there is nylon, so I'm going to strip this one as well. So I'm kind of leaning towards taking the damn thing to bits, getting that gear out, and seeing if I can make a new one. But I'd really appreciate your thoughts. Yeah, do let me know in the comments down below, and you know, if you enjoy this kind of rubbish, then do hit the subscribe banner and the notification bell. And thanks for watching. Sorry it's been so long since the last one. It's just been this project is just fighting me every step of the way. So we'll get there in the end. Cheers. Take care. This I've stripped it out, and this is the damage. There's a bearing at either end, a little nylon part, and it looks like it's pinned to the shaft with a couple of roll pins. So it's a relatively simple part, and the interesting thing is that it's only worn out where the load is. So I do actually have some teeth in good nick, so I can actually make some measurements. So I think maybe the thing to do is to try and machine one of those out of a chunk of brass. Oh, this project just goes on and on. It's the project from hell. God dear, I'll be glad when I've finished it. Oh, it just gets worse. Ah.